Happy 2023, welcome back. So this year I'm going to be looking at something a little bit different. I'm going to be looking at how we deploy OpenStack on top of OpenShift. And as part of that, I want to learn as much as I can about OpenShift and its upgrade process and the various aspects that I'll need to integrate with as part of that exploration. So you might have seen at the Open Infra Summit last year, Red Hat announced that we'll be moving the control plane services onto OpenShift. And we'll be doing that in a project that we're referring to as Podified. So we're going to take a look today not at that specifically. We will definitely make videos on that in the future. But today I want to look specifically at OpenShift upgrades and how they work, because I find the whole process actually quite interesting. It's very stable compared to what you might be used to with other platforms on the market at the moment, whereby like each upgrade is tested and then we release supported upgrade paths. So your version might not be able to upgrade to a handful of other versions. It can only get to these supported versions that we have vetted and we know work. So there's a bunch of processes that come together to make all of that possible, but I want to look specifically at the ClusterVersion operator today and how it manages to handle that upgrade process and what actually happens. So we're going to be looking at the code of that and try and understand a bit more about how that works. So we can see there just a quick snapshot of that's OpenStack running on top of OpenShift. There's a few things that have crashed there for various reasons, but that's essentially what we will be looking at eventually, is a bunch of pods that represent the control plane. But that's not what we're here to look at today. So let's take a look at get ClusterVersion. So we can see that I'm running 4.13. So I've been running this cluster since just before the break, like maybe end of November. I think I deployed this cluster. And I've been really trying to break it so that I can learn more about this upgrade process. I actually deployed OpenShift and then upgraded to OKD and then deployed OKD and upgraded to OpenShift, and I've moved things around and done a whole bunch of stuff. I've run into a bunch of interesting issues and learned a whole bunch of things that I didn't know before, which has been good. So if we take a look, this is failing because there's a problem with my with the console operator that I haven't looked into yet. Another thing I get to learn about. But let's take a look at how we get from one version to the next in OpenShift, and this is all handled by the ClusterVersion operator. So there's some really good information about this process available on GitHub. So there's three sources that I would generally recommend. The first one is the ClusterVersion operator page itself. So we can see here there's a nice SVG map of how these upgrades all come together. So if you wanted to follow through how things are upgraded and the workflow of that process, that's available as an SVG there that we can take a look at. Also under the dev folder, there's some more information about running it locally and just the general development stuff. But there's some good information on enhancements, really good information about a lot of different operators, and I would recommend spending some time going through these and looking at things that might be of interest to you here, because there's some really good information. And the other one is on the OKD GitHub itself, so OKD project/OKD. There's this really good introduction to release payloads, and this is essentially how OpenShift clusters are deployed and upgraded. So I'm not going to read it verbatim. You can go and read it yourself if that's something of interest to you. But this is essentially what we want to take a look at, is these commands that we can run to download the release payloads and have a look at what those payloads are. And they will become more relevant as we move through this video and take a look at the code. So as I've shown before, I'm running Mirror Registry. So each release I push into Mirror Registry and then I pull things from there. So what we'll do is we will download our release payload from Mirror Registry, and we'll take a look at what's in that payload and how that applies to our clusters. So we go back to the terminal. We're in the ClusterVersion operator Git repo here. So we do nvn package cbo.go. This is essentially, it's not the entry point, but it's essentially the place that you want to start looking if you want to understand how CBO works. So we've got a function here that just returns a new version of the cluster operator, and you can see there that one of the parameters it takes is this release image. So it's going to be provided a release image there, and that's a good clue for us to start with. And as we make our way down, we can see here we've got this initialize from payload. And if we read the comment there, initialize from payload waits until a ClusterVersion object exists. It then retrieves the payload contents and verifies the initial state, then configures the controller that loads and applies content to the cluster. So a ClusterVersion object. What is a ClusterVersion object? Well, that's an object that we can retrieve doing OC get ClusterVersion, and we saw that at the start of this video. So if we do -o YAML to see what is contained within that, we'll scroll up a bit. So we can see here that we have a channel, and you might be familiar with channels if you're an OpenShift user, and you know that you can have a fast channel, candidate channel, stable channel, etc. That's where our channel is defined. We have an upstream graph. So if we take this and curl that, we get a graph of all of the available upgrades from where we are. That's what I was referring to when I said the supported paths for those upgrades. Go back and keep looking through here. So in this case, we've got a desired update. Force is true because I'm not on a supported path with my OKD release. I'm just mirroring random images. I'm mirroring random releases that are made available in CI, and I'm just pushing them in the mirror registry. I'm never going to be within that supported category, so I'm running with force true. And then we have this release image here. So if we want to see what's in that payload that refers to, we can do extract. So we can do OCADM release extract and then pass it in a release that we want to take a look at. So we'll do this. We'll go to manifest. So we're going to run that command here. So we're just going to download the release payload, and we're going to push it into this release images directory. So in the release images directory, we can see a whole bunch of YAML files. So let's stop there, go back to CVO, and we'll keep following along with the code, and we'll see where we get to next. So this function is being used to download and initialize the cluster from that release payload, that one that we just took a look at. So let's find out when this is used. Initialize from payload. We'll just copy that. Do a search here. So not in this file. We'll do a search out here. Okay, so we can see it is run in this start.go file. So we'll see what happens in here. Okay, so scroll up a bit. So run launches a number of Go routines to handle manifest application metric serving. It continues operating until the context is done, and then attempts to clean shutdown limited by an internal context with a 2-minute cap. So this is just forking a bunch of processes, a bunch of threads to apply that payload. So we can see here. So here we can see it initializes from that payload, and if there's an error, then it logs the information. If there's a not, then we just increment the result channel count. Okay, so what we know so far is that we download this release payload and then we apply them to the cluster. So what we need to figure out is how that works. So the comments are super helpful. This is why, I just think if you want to understand something, the best way to understand it is just read the code. You're going to find out the most information about how it works if you actually read how it works. So even if you don't understand it, I would still recommend just dive in, have a look, see the parts that you do understand, maybe Google some things that you don't understand, and that's how you're going to learn more and ultimately become more confident using this kind of technology. So if we take a look at what a release image is expected to contain, we have a handy comment that explains that as well. So a release image is expected to contain a CVO binary, so a compiled version of the ClusterVersion operator, the manifest necessary to update the CVO, and the manifests of the other operators in the cluster. So during an update, the operator attempts to copy the contents of the image manifests into a temporary directory using a batch job. and a shared host path, and that applies the CVO manifest using the image for the CVO deployment. The deployment is then expected to launch a new process, and the new operator picks up the lease and applies the rest of the image. Okay, so that's super helpful information. So what we know is that it creates this batch job. So we can go and find that. So I don't think it's in this file. I think we'll find one called updates maybe, or something to do, something relevant to updates would make sense. Here you go. Upgradable, update payload. This looks promising. So let's take a look at update payload. Okay, so this file is importing the Kubernetes batch job. So I think we're in the right place. Okay, so here it is. So let's take a look at this function then. So this is the payload receiver. So we can see that we are extending the payload receiver with a function called fetch update payload to directory. So this goes through with a bunch of variables. So it takes in the image, the version we're going to be updating to, etc., and it is going to schedule on master nodes only. So let's go down, see what this does. So set container defaults. So this is creating the mount with the payloads by the looks of it. We got some security context there. I assume we need to be privileged because the comment before said it's actually a host path, so we need to be downloading these to the host by the looks of it. And then just some resource requirements. That's not overly interesting. So here's the job that is defined. So what do we do here? We launch a batch job. We create a temporary directory. So these are our init containers. So we create a temporary directory. We move the operator manifest to the temporary directory. So move and then the manifest, and move the release manifest to the temporary directory. Then we rename the final location. So we just do a move temp directory to directory. Then we mount the payloads. So host path, so there's the host path mount that we were talking about. Node selector, we use our node selector here to make sure we are only on those master nodes. And then here we actually, so this is the part that actually does go and create that batch job. So let's see if we can find that. We'll do OC get jobs in the OpenShift ClusterVersion namespace. Okay, that looks like it. Let's do OYAML. This looks like everything we were just looking at. So it is running that RMRF. It's using this image here, which is probably going to be our updated image. Make temporary directories. Here's the mount path here. So Etsy CVO update payloads. Let's see if that still exists. Like this is the first time I'm looking at it, so I don't know. I'm going to look at it the same as you. So we just do ls. We need to be on one of the control plane nodes because we don't schedule on workers. Okay, it looks like that exists. So we'll just log in here. CVO, update payloads. It is a directory, yes. Okay, cool. So we have manifest and release manifest, which is what we were expecting. So let's check out manifest first. Okay, so we've got, what do we have here? Let's have a look at ClusterVersion operator deployment. Yeah. What did I do? Okay, so this is the ClusterVersion operator deployment. What's it doing? So it's mounting a bunch of, it's mounting in the update payloads here, we can see. So I expect it will have a version here somewhere. And that version, when the version changes, we'll probably take an action. So we can see we run with the argument start with a release image. So that's probably what does it actually. That's probably where we get the release image from. But this is handy because we can see here we would be able to increase the verbosity if we wanted to see what it was doing. So we can probably find what this command does if we take that. Okay, so it's in this start file again. Release image. Okay, so here's the command line options we were just looking at. So let's see what it does with this release image. Release image. Okay, so it just launches it just creates a new version of the ClusterVersion operator with that release image in the as the arguments. Release image. Okay, and then we can see its reference there. Here's that deployment file. So here's that deployment file we were just looking at and how we get the release image in there. So this payload render.go looks interesting. Release image. So it passes that release image to this manifest render config function. Is that being imported or does it exist here? It might exist here. Manifest render. Here it is. Okay, so this render directory, what does this do? So this creates a new directory. It goes through and reads the files. So we're throwing away the index and the file in range files. If file is a directory, continue. Okay, so we go to another function called render manifest. Render manifest. So I'm not sure what this template execute does, but it's coming from the template library, which comes from text template. Okay, so this is what renders out all of those manifests by the looks of it. So let's just log back into our node. So we'll have a look at release manifest now, and this looks like what we saw when I did the extract as well. So this is all the manifests that are contained within this updated version. So let's take a look, for example, at MCO, so machine config, just as an example. So we'll have a look at the cluster operator object first. I don't have NeoVim here. In fact, I don't have Vim here. Okay, so when we update the cluster operator object, we can see that we're updating it and changing the version here. Okay, so what we can see there is that ClusterVersion operator downloads this image, it extracts and renders all of these manifests. So it extracts these manifests and then it goes through and applies them to the cluster, and then each of the operators is responsible for its own upgrade by the looks of things. Okay, so we looked at how it uses the release image and that downloads the manifest. We apply that, and then each of the operators have the relevant logic to handle the update. But the part we're missing is how ClusterVersion operator knows to do this update process. And that actually comes from the OC command itself. So we take a look at, well, I mean, if you look at the upgrade command, so we do cadm upgrade. So this is what an upgrade command looks like for me in my cluster, where I have to use force, allow explicit upgrade, and then I pass it in the mirror registry image that I want to upgrade to. Okay, so what happens when I run that command? Because ultimately that's what tells ClusterVersion operator that it's time to go. So if we do a upgrade, let's just do another find and we'll grep for upgrade here and just see what we get. Okay, so this looks like what we're after as this file here. So when we run OCADM upgrade, what's happening? So this is where we create the command line client. So yeah, this Cobra library is a command line library for Golang. So we're creating the client here with all the options. Run looks interesting. What happens in run? So cluster version or error is O client config v1, cluster versions get version. So we're getting the version from cluster version, which is we saw before, get cluster version is the same as if I do version. So there's actually an object called version under there. So it's getting that. Once it's got that, then we have some switch cases here. So, okay, so this first one is if we use the option clear, then we're going to check for desired update equal to nil. And if it is equal to nil, we'll say there's no update in progress. Otherwise, we're going to run a bunch of actions to clear the update. Now, this only works if you've run OCADM upgrade and then you try and cancel it straight away. If it's already downloaded, then it's not going to work. So we go down to latest available. That's not what I'm using, so we can skip that to latest available. No. So force, I'm using force for sure. So all we're doing then is we're setting update force equal to true. So we spec. Actually, it's a bit nicer if we just use JQ actually. JQ spec. Okay, so we're setting force to true. Yeah, so this is where I would match. So if update is equal to nil and the upgrade image is not equal to nothing, so we need to provide an upgrade image, and we are specifying allow explicit upgrade, then what we're going to do is we're going to update the config update version image. So we update this version image. So from ClusterVersion operator's perspective, it is watching this ClusterVersion object because it owns this object. Okay, so we can see here there is so we're extending the controller, so the operator controller here, and we're doing a sync. Okay, so what we do here is we get a copy of the ClusterVersion object, and then we are checking it to see if there's no update available. If there's no update available, we just return nil. If there is an update, then we're looking here at available updates. So we'll use this tab over here to get ClusterVersion -o JSON. So it's under status. Yeah, so you can see at the top, available updates is null for us. So this would always return nil in our case. So we can see we have a function here that reads from that spec. So update is equal to config spec desired update. So if this function returns an update object and true, then we are going to try and update. So let's find where this is used. So it's used back in the CVO. So yeah, this sync function here, so it ensures the ClusterVersion object exists, the ClusterVersion object has appropriate status and state of the cluster, the config sync object is kept up to date, maintaining the user's desired version, and loads initial update payload releases. So this is the function that will do it. So we're extending the operator. So here we go, started syncing ClusterVersion spec changes status and payload. So here's where it uses that function. So it reads in the spec that we've updated, the image that we've updated to. So desired version from spec is blah, blah, blah. So this is logging it. So maybe we can find, let's see, gets and OpenShift ClusterVersion. And if we do logs, version. This one, and grep for desired. Okay, so desired version from spec. So there's that log message that we're looking at, and we can see that it has an update object like we saw being returned before, and it gives it the image and false equals true. So cool, that's where we're up to. So if okay, then klog that, else operator, right? So we're good, we don't match on any of that. We go down, if the length of the desired image is 0, which it's not. Okay, so then we go and we do this sync loop. So payload, updating payload, where we do updating payload, which comes from here. Updating payload. So updating payload indicates we're moving from one state to another. When we're moving to a different payload version, we want to be as conservative as possible about ordering of the payload and the errors we might encounter. An error in one operator should prevent dependent operators from changing. We're willing to take longer to roll out an update if it reduces the possibility of errors. And then we can see there's just some logic to make sure that only the right things are updated there. So, you know, we can probably walk through all this code all day, but I guess the main takeaways that I wanted to make people aware of here is that there's this release image, and anyone can download the release image. You can download the release image and take a look at the various artifacts that are contained within that image, and it'll help you understand more about how this actually works. We have a look in our release image directory again. That's something like maybe the network operator. So cluster network operator, we can see, you know, there's a deployment for it. We can take a look at what that deployment looks like. We can have a look at existing things within the cluster to see what's the difference between what I have deployed at the moment and what I'm going to be applying if I were to apply this update. Like if we were to get that same object here, so OC get OpenShift network operator, deployment network operator, show YAML. So this is what we have in the cluster at the moment. And should we apply this update, you know, what would be changing? I can sit here side by side, look at them and understand what's going to actually change in my cluster. And I think that's the important thing I'm trying to stress when we talk about learning new things. It's about exploring, understanding exactly how things work. And in this case, we've walked through a lot of what the ClusterVersion operator is doing is just downloading that release image and figuring out what needs to be applied to the cluster, what doesn't need to be applied to the cluster, and then monitoring that. So it keeps monitoring those cluster operators to see whether they're finished. And in that last file we were looking at, we were just looking at how it determines what does need to be applied and what doesn't need to be applied. So when we go to the load update function again, you know, it's going through known capabilities. It's checking to make sure that it's only updating things that are enabled within your cluster. Like if we look at that cluster object again, ClusterVersion spec. So we can see within the ClusterVersion object, we have these enabled capabilities and known capabilities. So it's iterating over them and making sure that it's only updating things that are enabled for your cluster. It also checks to make sure that things that don't need to change don't actually change. For example, like, you know, if there was no change made to the DNS operator, it would just change the version. It's not going to go and do a whole rollout of different things. It's always doing that rollout anyway, you know what I mean? Like it's not actually going and changing anything about it. It'll just change the version and everything else will keep running. But just as the ClusterVersion operator reconciles, it's always doing an apply of the release images to maintain consistency within the cluster. You know, it's obviously not a comprehensive walkthrough of the ClusterVersion operator in this video, but I hope it's enough of an insight that people can like get started, dive into it, understand how things are happening. It's one of my favorite things about Red Hat is that all this information is available publicly on the internet. Anyone can go and get cloned, start reading through it, start diving into their own clusters. So if you haven't already, deploy something from crazy release that you download from. I've touched on it before, but just for consistency, if you go to AMD64 Origin releases CI OpenShift org, you can see all the releases here. So for me, I'm just picking one at random from here. Like this one looks fine, and then I'll upgrade to it. So I copy that, go back to console, log into my Mira registry. So we log into our Mira registry VM. Tmux attach, registry clone. So if I go down here, we'll paste this one in. So we can see we're changing from the 12th to the 15th, so extra couple of days here. And then bash registry clone OKD. That'll clone in that release from that image, and I can then perform an upgrade in this cluster. So to summarize it, what we know about it is when we do that upgrade, the OCADM upgrade, the client itself updates the desired update object with the new image. ClusterVersion operator goes through and it's always checking that. It's always checking the ClusterVersion object because it owns that object. It's always watching it. It sees that change and it goes, hey, that's different to what I'm currently running. Let's launch this job. We'll download the new release image and compare that to what we currently have, and then we'll go through and we'll apply that. And as you can see in like an image like this is how that workflow actually looks. So it applies the CRDs, and it goes through and applies the next lot of things, and it makes its way all the way down until it's finally ready to finish its job. And if you want to know more about it, then we have a whole bunch of information available on the enhancements repo, which is really handy to look through. There's a whole bunch of information on the OKD repo, which is really good. Definitely recommend checking this one out. There's a bunch of troubleshooting information as well. It's not just about updates, but just troubleshooting in general. If you wanted to build your own releases, which is something I highly recommend doing because it's an interesting process, it is a good way to understand how a patch would make its way into OpenShift as well. Like if you needed to patch something within Prometheus, this making changes section that I'll link all these below, but the making changes section is how you would figure out what level it's currently up to and how you can build your own image from, say, a different commit. You can see the commits that they're built from. I think it's also in here, commit URLs. Yeah, so replacing other images. So you can see here if you do the OCADM info and then on the commit URLs, that will show you the latest commit from each of those projects. So you can look at that latest commit and say, hey, the change that I need to include was actually 2 commits after this, and you might be able to rebuild yourself a new image, publish your own release to Mira registry and upgrade to it. And that's a really educational process. Highly recommend doing that. So look, definitely not a comprehensive overview of the ClusterVersion operator. That wasn't my intention. My intention is really just to provide some insights and things that I've learned over the last couple of months while I've been digging into this and trying to understand it more myself. I hope it helps you to understand how this technology works and makes you more confident in using it. Definitely encourage everyone to go out there, deploy their own clusters, build their own releases, upgrade to them, try and break it as best you can, try and understand why it was broken, try and look through the code to find out where you're getting up to and why you're not making past it. That's how we learn more. Every breakage is an opportunity to learn something you didn't know before. So look at it that way, take advantage of it, and I hope you enjoy your exploration. I hope it's helpful.